We are going to practice simplifying radicals. So if you want to just jot down these examples as we go, that would be great. Okay, let's look at our first example. The square root of 50, I want you to simplify this radical. Now, if you've learned this before, there are a couple different ways to teach this. A common one is like by doing a factor tree. I'm going to show you another efficient way if you haven't learned this already. So let's actually review the factor tree method because this is probably what a lot of you guys have learned. So, okay, so you've got your square root 50 right here. Now you want to branch this out, and for the factor tree method, you can pick any two numbers that multiply to give you 50. So I might think 25 times 2. Okay, and then you want to continue to break this down until you can't break down the numbers anymore. So like 25 can be broken down 5 times 5, right? Now 2 can't be broken down any further unless it was 2 times 1, right? So what I'm going to do, and I always bring everything down, I would just bring this straight down, make sure you write it. And of course, let's put that multiplication sign in between them. Now if you look at this, these cannot be broken down anymore. So what we do, when you make it all the way down after you've done the factor tree, you look for pairs of numbers, and I always circle them. So we end up with a pair of 5s right here. If you don't have any pairs in the end, that means that this can't be simplified anymore, and that would just be your answer. But this can be. We have a pair of 5s right here, so whenever you have a pair, circle them, and that just means that a single 5 can be factored out. So don't bring out 2 5s. One pair represents 1 5 that you can bring out. Now the ones that don't get paired up, like the 2 right here, that is left in the radical. So this would simplify to 5 root 2. Okay, now I want to look at this in a different perspective. So let me erase this. So you can do the factor tree method, that works every time, but sometimes you're going to have like much larger numbers where you're going to end up breaking that down really far, and it's not very efficient. So the most efficient way to actually simplify radicals is to think of the largest perfect square that goes into that number. So a good way to think about this is whenever I'm doing like a bunch of simplifying radicals, I'll just write off to the side of my paper all the perfect squares like that I can think of. Just as many as I can. So like the first one would be 4, right? The square root of 4 would be 2. And so just kind of square numbers in your head, right? Like 2 squared would give you 4. 3 squared would give you 9. 4 squared would give you 16. Right? So you can write a bunch of them. But this is helpful, especially if you're taking a quiz over this stuff. Just write this off to the side of your paper. It's going to help you. 49. So it's good to know your squares. I'd say up until like 15 or so. Okay, but we'll stop there for this one. All right, so what would be the largest perfect square that goes into 50? Well, we know that would be, the largest one would be 25. So I'm going to break that down to 25 times 2, right? So what we found is a perfect square that's within 50 because the square root of 25 is 5. So you're basically breaking it down into something you can take the square root of. You can take the square root of 25, square root of that is 5. This one would be left in the radical, 5 root 2. So we get the same thing no matter what. So it's really just personal preference which method you like more. But like I said, as these numbers get larger, it's not going to be very efficient to do like a bunch of factor trees because you'll have a lot of them. It'll take a long time. All right, so let's try this one. This one's just a little bit different because we do have a number outside of the radical. So I would read this as 3 root 20. Okay, but technically it's 3 times root 20. So don't forget, if you see like a number right outside, that's multiplication that's happening. Okay, so we don't actually need to worry about this 3 until the very end, so I'm just going to leave it alone and look at my square root 20. Okay, so what I'm going to do is I'm going to think of the largest perfect square that goes into 20. So what would that be? And of course we don't have our numbers here, but we could do them again. Etc. Right? So the largest perfect square that goes into 20 is 4. Right? Could do 4 times 5. And then we can take the square root of that. Square root of 4 is 2, so I can bring a 2 out of the radical, and then I would be left with 5 inside the radical. As long as you're taking the largest perfect square, then you'll only have one step because you'll take the square root of that number and then this one will just be left inside the radical. Now, if you don't pick the largest perfect square that goes into the number, then you're going to have some more work to do over here. So always try to find the largest one that goes into that number. Okay, so we're not totally done. We do have this 3 that we've got to deal with now. So we have 3 times whatever number we end up with out here, which in this case was 2. So this would equal 6 root 5. Final answer. Now, you can actually check to see if you did it right in your calculator. In your calculator, try this right now. Put in 3 root 20, or 3 times the square root of 20, and press enter. I'll do it too. You guys should be doing this. So 3 square root 20, I press enter, I get like 13.416, etc. Now put in 6 root 5, what we got down here. You should get the exact same number when you enter it in your calculator, 13.416. This is a good way to check and see if you've simplified correctly, because these are the same value. This is just a simplified version of your original problem. All right, let's try another one. Example 3, 5 root 600. Okay, so you can see the number is already bigger right here, so you may not want to do like a bunch of factor trees. So again, I would think of the largest perfect square that goes into 600. Now I paused it and wrote all these down off to the side, which you should still have on your paper somewhere. I did expand it a little bit more though. I wrote down some more numbers. All right, so, and you can even write down more, 12 squared, 13 squared, 14, 15 squared, etc. But if we look at this column right here, the largest number that's going to go into 600 is 100, right? So we could branch that out. 100 times 6, okay? I can take the square root of 100, which is 10, so I'm going to pull that out, and I would be left with 6 inside the square root. Now, what if you're thinking like, well, how do I know 100 is the largest perfect square? What if there's a number bigger than that? If you're not sure, after you take the square root of 100, try to do a little factor tree on this other number. That would just break down to 3 times 2. There's no pairs of numbers there, so we obviously did pick the largest perfect square. Otherwise, that wouldn't happen. You'd have another pair of numbers here to pull out. Okay, so we picked the largest one. We're left with 6 inside the square root. Okay, now we also have this 5, so we'll deal with that in the end always. Just don't forget about it. So we have 5 times 10 root 6, which you just multiply the outside numbers. That would be 50 root 6. And again, you can check your answer in your calculator by putting in 5 square root 600. Press enter, you get 122 point something, and then 50 root 6. Put that in your calculator, press enter. Again, you get the same thing, so we know we simplified it correctly. All right, let's try another one. So we're multiplying radicals now, square root 2 times square root 6. Okay, anytime you multiply radicals, you can either simplify them individually first and then multiply them together, or you can multiply them together and then simplify the radical. Okay, so it's really just preference here. If I look at them, I actually can't simplify either of these anymore, right? 2 is not going to break down. 6 breaks down to 3 times 2, but there's no pairs that you can factor out. So let's go ahead and multiply those together. Whenever you multiply radicals, if there are numbers on the outside of the radicals, you multiply those together. If there are numbers inside the radical, you multiply those together. So this would just be the square root of 12. All right, and then we want to see if we can break this down a little bit more. We can simplify this. Think of the